Here it is again, using the blue laser. Let's see if I can get it right on there. Ah, there we go. Look at that. So mostly I just wanted to use the blue laser, but it shows that it's not color dependent, or I should say wavelength dependent.
Let's talk about the demonstration in the previous video of the laser hitting the water coming out of the spout. And what you saw there was total internal reflection. What's happening? Well, let's take an example to explain it. So here is air, here is water, and here's a little fish who's studying physics. So of course he's carrying his laser with him. Now, when the fish shoots his laser, as illuminates his laser, light comes out, hits the surface, and it's going to refract. And which way will it refract? Well, let's draw the normal line first. So this would be the normal line. This would be the incident angle, which I'll call theta 1. I'll call this N1. And air will be the N2. Now, theta 2 has to be larger because air has a smaller index of refraction, so the light will bend away from the normal. And so the laser light will come out like this. Okay, that's all very good. What happens if the fish tilted just a little bit more? So if he tilted just a little bit more, then the light will come out just a little bit over here at a bigger angle. So now this angle is increased. And let's say he puts it at just the right angle so that it refracts all the way and floats across the surface. That point right there, this situation, that's called the critical angle. Anything less than the critical angle, it refracts. Anything larger than the critical angle, it reflects. Now, we can always find the critical angle using Snell's law. And we know Snell's law is N1 sine theta 1 equals N2 sine theta 2. So, for our case, water is the N1, and then that'll be sine theta of the critical angle, which we're trying to find. And then that equals N2 sine, well, what is this angle? It's 90 degrees. So it's sine of 90 degrees. Sine of 90 degrees is 1. And I can now solve for sine of the critical angle. Sine of the critical angle is simply N2 divided by N1. Now, perfect. So, now let's talk about the case where he goes beyond the critical angle. So the fish points it a little bit further out now. And now, the incident angle, so let's erase this old stuff. Here's the normal line. Now this incident angle is even larger than before, and it reflects instead of refracts. And that's what we saw over by the sink when we were shining the laser through that column of water. The angle was such that the laser light was reflecting in the water. So here's the water coming out, the spout of the water, and the laser light is being totally internally reflected. This is how fiber optic cables work, and many other phenomena in industry and nature.